Hi there, my name is Steven, and welcome back to C#, .NET, and Windows. Today we're getting into the methods, constructors, functions, access modifiers, and maybe a little bit more. I'm going to try to hurry through this because I'm using a different camera this time, and I'm going to see how I like it. I'm using my recreational DSLR, but it doesn't have clean video out, so it shuts off after about a half hour, and I can't record with it. I'm basically doing a live stream with it. So if it doesn't work out, that's fine. No problems whatsoever. I'll just go back to my little Canon Vixia that I've been using. So this has actually been the camera that I've made all the other videos on, as well as live streaming. Actually, this has been an incredible live streaming camera for me. So I might pop back to that. 1080p, nothing fancy. It's not like I'm streaming in 4K. You might actually see some blurring around like my hair edges and stuff like that, but what are you gonna do? We're gonna try this out and see how it goes. So anyway, long introduction, but let's just jump right into the code and talk about access modifiers. So what is an access modifier? An access modifier is used to, or it's a keyword that's used to set the access level or visibility, so to speak, of classes, fields, methods, and properties. I talked about it a little bit in the last video where we talked about the classes that we were using for grocery list and things like that. You'll see public here. I can't remember what the implicit is. I think the implicit is public, but I could be wrong. In this case, though, you'll see, you could probably write out public there. Let's see if it throws an error on me. It doesn't. So we've got public class there. Access modifiers essentially treat your class in certain respects. So it allows things to access properties. So in this case, say grocery list. Instead of setting items publicly from outside the class, we only want items to be set from within our constructors. And yeah, we'll get into constructors in a little bit. But we only want to be able to set items via these constructors. And since both of our constructors are setting items to a new list or to a list that we've predetermined when calling the constructor, we're allowed to do this without having to worry about loss of data or any unexpected data cases. So we're going to hop back to form, and you'll see that items here has a syntax error, and so does items down here. And if you hover over, you'll see grocery list.items is inaccessible due to its protection level. Protection level refers directly to the access modifier. So if I were to go to here and change this back to public or internal, that syntax error goes away. So what's the difference? A public access modifier sets it so that the code is accessible for all classes. So we could write a plugin that hinges off of our primary code here or inserts information into our code here from a different project. You could have it just anywhere in this project itself. So if you went to Solution Explorer, you might have, say, added a new project here, and we'll call this test 1 just for sake of time. And I want this in Windows specifically. What the heck, I guess it doesn't really matter. We'll do unit test app for Universal Windows. It doesn't matter, but fine. That's fine. Just add it. Come on. I don't have that much time. So we have this other project here. So technically, I could add a reference to my first application here. Oh, it's because they're different frameworks. Okay, well, it's not an exact science, despite it being literally an exact science. Jeez, I don't know. Just Windows Forms app. That'll be fine. Yep, that's fine. And we'll go into the back end of the, not the designer. We'll go into our form 1 here. Well, let me add a reference here. Yes. So, if you're going between classes or between projects, if you wanted your secondary project to reference the first one, in this case Windows Forms app 1 to reference first application, you have to go into your references under the project you want to reference. We'll call it the sub project. So you go into your sub project references, add reference, and you can go to projects solution and find your other project. The only ones that will show up in the project solution tab of Reference Manager are going to be ones that you'll see in Solution Explorer as well. So from here, we should be able to actually type in grocery list, and it shouldn't show up yet, but since we have the reference, we can create a new one. I don't have an empty constructor, and we'll talk about empty constructors. And then that should be valid. And then if I go to GL dot, we have created date and we have name, but we don't have items. That is because this is set to internal. Internal means that only stuff that's in the first application project can access items from or for this class. Now, internal is the code is only accessible, the actual definition of it is the code is only accessible within its own assembly, but not from another assembly, so another project or another solution. Private is the code is only accessible within this assembly or within the same class. And protected actually is used primarily when you're talking about inheritance. Protected is code accessible only within the same class or in the class that is inherited. So if we had our human object again, back to human, had our human object and we had a protected variable or property in human, it would be accessible to anything that inherits human, so male and female, but it wouldn't be accessible outside of those derived classes, and vice versa. Not vice versa, because inherited isn't reverse referential. So male, female would be able to access protected variables from human, and that's it. Nothing else could reference those. Again, access modifiers, the three that I use are public, protected, I just read it on my screen. Public, private, and internal. There are certainly reasons to use the others, as I just stated. A lot of it is for application security. It's making sure that nobody can tap into specific classes or data that you're manipulating in the interim of being in memory. If you're more memory conscious about that, there are a lot of if you're more security conscious about things like that, you can go to your articles on like W3 schools and get a brief case of it or overview of it. You can also go to .NET Pearls. You can ask on Stack Overflow. I'm sure it's been answered a number of times. But do a little bit of research on that, and it will give you a use case, because your specific instance of code may actually require you to use the other two primary access modifiers, being protected. Actually, no, it's just the one, protected. The other thing that we should really cover while we're in access modifiers is the concept of a static class. Now, you'll hear me typing because I'm bringing stuff up on my other screen from my notes and making note of things I need to talk about. Static classes are ones that can't be instantiated. You can't write a constructor for them. So remember the cake analogy? This class definition that you see here in grocery lists, I'm actually going to unload Windows Forms apps here. This is the recipe for a cake, so to speak. When you instantiate it, you're actually baking the cake from the recipe. Instantiated classes are, static classes are ones that can't be instantiated. You can't bake a cake out of them. You can access all of the properties about them, but you can't make one. And that seems really awkward or really confusing. Granted, I use static classes for data manipulation, and I'm sure a lot of people would use them for different kinds of, well, no, not even that. I use them for data access layers, essentially where I dump a bunch of REST handling, REST API handling, SQL or MySQL or Mongo database access. And I would usually go through and add something like a folder to classes, and then I would add this class, and I usually use the naming convention of handler post the subject of what is being handled. In this case, we're just going to say data handling. So technically, this could be a file IO class. So you would do internal, or I would, internal static. Let's just do void. And we can do string path. And we'll just return success. This part I'm making up on the fly just because I can. Because I didn't plan on talking about static, but the more and more I think about access modifiers and where static comes into play, the more I think this would be appropriate here. And we'll declare this as a static class, and we'll make sure it's internal. We also need to talk about getters and setters in this episode. So now that we've got internal static string get files, and it's matching internal to internal, which you don't have to. You could do internal and private. We'll get into that with getters and setters a little bit more in depth, I think. I hope. You can see that this get files, this data handler.get files, this is how you use a static class. If I were to do, say, var test data 1 equals new data handler, throws an error. Cannot create an instance of a static class. Why in the world would you do this? Again, it's about being memory conscious. By doing a static class or by creating a static class, you no longer have to worry about garbage collection or issues that may cap out the amount of memory you have. If you're running on low memory systems that are running maybe nowadays 2 gigs, 4 gigs or so, you can run into problems where you are overusing memory and it just munches through it. Think of Google Chrome as an example. If you have ever opened up Task Manager when you've had 5 or 6 different Chrome tabs open, you'll notice that Google Chrome actually burns through and uses so much of your memory for a number of background processes. Static classes allow us for many things that don't require data retention to use them, abuse them, and ditch them. This is why I use it for data access, because I'm hitting my database with a request, and then I am dragging that data over into memory for my application, and then the database doesn't matter anymore in the context of that transaction. The database connection can go away because I've got the data I need in memory. There's no reason for me to hit the database again until I absolutely have to. Static classes, again, I don't use super often, as far as I don't have a ton of them that I need to implement in code on a regular basis, but my data access REST API handlers, SOAP API handlers, database access, entity framework, I think uses a lot of static classes. I could be wrong on that. Entity is still something that swims around in my head quite a bit, and I haven't had a chance to dive into. So that's static. Let's talk about getters and setters, because I just talked about it briefly. You may recall in our last episode that we talked about this get set, getting a value, setting a value for this variable. These reference directly the variable that they are child methods of, so in these curly brackets. Let's actually use a really cool Visual Studio tooltip or shortcut. You can type in prop, just like we did for the ones above in the last episode, but you can also hit F, and this will create a prop full entry. Hit tab twice again, and you get this full property. A full property defines a property with getters and setters for us, as well as a public-facing entry point and a privately facing entry point for data retention and, once again, security through a a small amount of obscurity. So in this case, I want to make a string. I want to call this, say, description. Now, it's important that you have a naming convention for private and public here, because you're only going to be accessing private variables through specific ways and methods, because you don't want the user input to go directly to those when handling the data moving forward. You want to manipulate from that as necessary for your class. Again, this is an instantiable. This is not a static class. This is a standard POCO, a plain old C object, or a plain old C# project or object. My brain is a little fried today. It's been a stressful one, so I'm a little bit tired, but we'll power through. So string description, you'll see this naming convention quite a bit. The underscore delimiting that it is a private property. And then you can drop down to here and give this your proper title case or camel case, depending on how you like to do it. Now, let's break down what happens in this public string description property. So say I have a user front end text box where somebody is going to enter in a description for my property or for my list, the list that they are creating. We would data bind to this, which means to have the value, or have a specific value of a front end control, like a text box, button, checkbox, radio button, etc., tied directly, implicitly to a specific property, like description. We would have a text box that anytime the text box on the front end is updated, it notifies the system, and the system updates this particular method or this particular property, description. When we set description, the public form, we also listen in and say, oh, hey, this is now updated. The current description value has been updated for the public property. We're also going to set our private variable to the value of description. And you can put business logic in here. If it matches this, if it doesn't match that, if it does this but not that, if it, so on and so forth. You have whatever business logic you may have. You might even do mathematics in this if you're doing a banking application for withdrawals or deposits, for credits and debits. You may have some obscurity here for your private, but also some business logic within the actual setter of your private value in order to be able to manipulate that data in a maybe a little bit more clean way. When you're getting the value, when you hit the public string description, that property, you're actually getting the value of the private property. Now, why would we do this? The underscore description value can have a totally different name than the public one. So your private can be something like this, except, actually I'm surprised it'll let me do symbols there, because you can't have numbers at the beginning of your variable names. We didn't cover that in variables because I never do it. It's a good habit to get into, to not try to name your variables starting with a number. So this XYZ with underscores scattered throughout it is harder to decompile and understand what it does because you can't read a variable name out of it. It's secure because it is obscure. Nobody would be able to think, oh, XYZ is going to be description of a field or a property or an object within the application. That being said, there are a number of other reasons. There are a number of other reasons for doing a full property like this, but for me personally, I usually do it in some sort of observation of the iNotify property changed interface, which is used for data binding primarily, if not exclusively. That's pretty much the getter setter stuff. I mean, if you think as minimalistically as possible about the words get and set in relation to your variable, it makes a lot of sense. I'm either going to get the value or I'm going to set the value. I'm either going to get the value of name or I'm going to set the value of name. In this case, we're just pawning off the value to a private variable for manipulation elsewhere and obscurity, so that we can avoid people easily being able to break down what we're doing in our code. Next up, we have constructors. Again, we talked to a degree about this last week because we got into classes and complex variables. This particular method you might recognize as a little bit different than our other one. Let's pop this out so we can see them side by side. Than the other ones you're used to seeing. Now these are event handlers, which is another thing on our list. So constructors are going to be a specific kind of method. And I probably should talk about constructors after methods, but it'll be fine. They're the same thing, except methods are more broad. Constructors are methods that are specifically used for creating or instantiating, which is our fancy word for creating an instance of, if you recall, a class. So we're creating this public grocery list, or we're creating this grocery list object with these properties populated by passing in a name. If you look at a standard method that is not a constructor, you would see something along the lines of public void create grocery list. Let's do grocery list. So you have your access modifier, and you have your grocery list here, which is your class name, not your method name. And in a standard method, you also have what is known as a signature, or at least part of your signature. This would be your return type of your signature. Method signature, not your actual handwriting. So, man, it would have been easier to go the other way around with this, but that's okay. My fault. We have an access modifier, and with a constructor, your method name, your constructor name, has got to be, by requirement of the compiler, the exact same as your class name. Otherwise, it is no longer a constructor. It becomes a method. And this is fine. We can do this. Generally, your constructors are your first methods in your class, because logically flowing, that's just the way it goes. You need to create the object before you handle anything within it or around it or create an instance of it. So you may notice that the grocery list items or the grocery list constructors are the first methods in the class. That's because logically speaking, you want to create the object before you manipulate it or before you do any logic with it. It's a convention that's used. It's not required. I mean, I could move these in any which way around any other methods or properties that I see, but typically in a class you're going to have your global variables or your class level variables at the very top, and then right below those you'll have your constructors, and then below that you'll have your methods and functions. The grocery list constructors in this case, you'll see, do not have a return type. Constructors don't have a return type. You're not going to see void, you're not going to see string, you're not going to see anything like that. You're going to not see that because they don't return anything. They simply create and populate properties of a class for that instance. Methods, which are easier to explain, and functions are actually even easier to explain than methods, because I decided to do this all out of order because I'm ridiculous like that. Methods are essentially verbs in your code. Your verbs are your actions, your the function of the program, manipulation of data, or presentation of data are all going to come from methods or functions. Methods specifically have an access modifier. They have the potential to be static, as we saw with our other example, which I can't for the life of me remember, for our data handler. Or it might not be static. I prefer that I don't use static methods if I don't have a static class. I'm not sure why this is not a syntax error. I've never seen it where somebody has had an instantiable object, like in this case grocery list, and had a static class, or sorry, a static method in them or function. So if it's not a static class, don't put static in your method or function calls, at least for now. You'll probably find something out there that contradicts what I've just said, but for the ease of your organization of your mind and your journey now, it's easier to just remember, no static class, no static method. No static class, no static function. Static class, you have to have static functions and methods. Otherwise, it throws off the access modifiers and ultimately causes a lot of confusion for anybody working with you, especially if they're working on your code. A method is really key to remember that it is simply a verbiage thing that is called a method. Because literally the only difference between what is known as a method and what's known as a function is that a function returns a value and a method does not. A method, technically, is always void. Technically, constructors are constructor methods. But that gets confusing. These are constructors. These are method, or this is a method. Now, if I were to do this, public string create grocery list, and then return an empty string or return a string of some sort, that is now a function. You'll hear the term method used to describe functions. You'll hear the term function used to describe methods. It depends on the languages that you're using. I believe everything in JavaScript scripting is everything is a function because everything returns a value of some sort. I could be wrong on that. I'm not a JavaScript expert by any stretch. But the point is, in C#, this is a function because it returns a value. If it didn't return a value and the signature included void, then it's a method. And that's the only difference between methods and functions. So a constructor is a method that builds the class without a void or a static signature. A function is a method that returns a value. That's as simple as it can get. That is straightforward, as simple as it gets. Event handlers are really interesting because typically you'll see void. I say typically because there are some instances where if you get into Xamarin development or anything like that, you'll find that they can sometimes return task T's, which are generics for multi-threading, which will be a separate lesson. I don't know when I'll be making that one, but I will at some point. The key here is to remember that an event handler handles an event. Duh, right? Like, go figure, Steven. Thanks. I really appreciate you spelling that one out for me. I don't think you're an idiot. Sometimes jumbling the words around like that can help it lock into your head. An event handler is a method or function that handles an event. An event is described as an interaction that updates data in some way, shape, or form. It can be from an automated system in the event of data handling, or more typically, event handlers will be raised and fired, which means like a gun, they're fired. They're in action when you fire an event handler. When a person interacts with some sort of interface or typically a form, fills out text or checks a box or hits a button or what have you, it then sends that data to an event handler, just like our button clicks have all along, and then it does something with that, whether this gets offloaded to a method or a function or what have you. The code that I've shown you up till now has been really sloppy, and the reason for that is for simplicity of education for you. Best practice dictates that this is not in this logic that I have highlighted would not be in the button add value click event handler, because click is an event triggered by a user that then does this logic. Visual Studio offers something really nice. A lot of IDEs actually use it now or offer it. It's called extraction. So if you highlight a certain amount of code, Visual Studio will intelligently or semi-intelligently offer a way to extract that into a method by hitting Alt-Enter on it on a highlighted section of code. Hit Alt-Enter and then hit Enter again, and it will create a method for you and highlight the name. So now you name it anything you want. And then hit Enter. Why? Why not just throw all of our code in our event handler? Well, because it's important to note, it really is, that an event handler is meant to just shift things off of it. Once something happens, or once a user clicks a button or some sort of data is updated, the event handler says, hey, time to do something, method or function here, do this thing. Really key separation of concerns thing, and this is an industry standard, is that your method or function should only do one thing. One thing. For instance, say you want to create a point of sale application and you have a ticket where a server has entered in a soda, a burger, and some fries, and the total bill comes to $14.99. Well, that's your subtotal. That's the value of the sale price of each of the items on the ticket. But now they've entered in, and this person, the customer, wants to cash out, or they want to pay their bill. The user, the waiter, is going to click on that ticket or the pay button for that ticket, and your system has to calculate tax and calculate total from your subtotal. Well, in that case, calculate tax should be its own method, and it is its own function, and it's a function because it would likely return a double value. And then your calculate total is going to take the sum of your subtotal plus your tax less any discounts, and calculate total discounts from ticket, which should be another method or function, and then output that value to the end user screen, the waiter's screen. So in the state where I live, we have a 6% sales tax. So if you have $14.99, I can't do math that well, but if you have $14.99 times 1.06, it's going to be roughly $15.89 for your burger, fries, and soda. Those three things need to be separate functions because each one is doing something specific. If your method or function is not specific, it is overwritten and it needs to be broken down into more bite-sized pieces. The reason for that is because separation of concerns allows you to be able to run calculations from multiple places or run any kind of data manipulation from multiple places and therefore offer less jumble. It allows your program to be a lot more mutatable or buildable, what's known in the industry as scalable. It also allows you to organize your code more appropriately based on function or necessary feature set. So when the next developer comes in to work on your code, you don't have to worry about them not being able to read it. And I've run into event handlers that have had 400, 500, 600 lines of code in them, and it's awful because you don't know what anything does. You don't know why anything is relevant. Everything's just done right in the event handler. It can also cause some hangups with your UI. It's really hard to multi-thread an event handler. So it can lock up the UI and give you that not responding message when somebody's trying to do something. Best practices dictate it's really simple. Just break out your methods and functions into individual chunks, individual functions and features, and then call them from your event handlers. It'll make your life way easier, I promise. Just get in the habit of it early on, and you'll be golden. So we could do this, and instead of that, go down to extract method, and we're going to create our grocery list. And then this one down here is going to be handle selection. It could be handle grocery list selection. This could be load UI on grocery list selection. This could be any number of things. And technically, this here I accidentally full screened my application. Nah, that's not what I want to do. Technically, this should be split out into update app title, because now I can call this from anywhere. So yeah, that's a pretty basic way to really easily clean up your code. How did I just roll up all of that? Roll-ups are these little plus and minus signs off to the side. How did I roll it all up? Control M-O. Control M-O is a beautiful, beautiful, beautiful thing because it hides everything up into the roll-ups, and then you can expand only what is relevant to what you want to read about. If you want to expand them all, say you're scrubbing through your code, hit Control ML, and it will lengthen all of your code roll-ups. It's really, really handy. So I've talked about signatures. I've talked about what they are briefly earlier in the video, and I've referenced the signature a lot. The signature of a method or a function is a combination of the arguments passed in, such as what's done in this particular constructor here, as well as the return type. So the signature of create grocery list here is void. Void and null. You'll never hear somebody talk about signatures unless you're learning about signatures. More often than not, they just talk about the arguments that are passed in or the return type separately because they're not often bound together. But you can't have public void. Been working on other projects too much. I'm starting to write creature instead of create. Sorry about that. That would be my cat, or one of them. So public void create grocery list. Why is it red? Because we already have one, right? Already defines a member called create grocery list with the same parameter types. It's the same thing. It's a signature. The parameter types. If I were to do this, it also won't work, by the way. Because even though we've changed the signature part here, the compiler will get confused on which one we mean. So now if I just do something like this, now they're different. Because the signature, the combination of the return type and the arguments passed in, are now different. I could call this, or I could call this. So if I go to here, I just need a place to dump this for the time being. If I go grocery list, GL equals new grocery list, fat fingering like crazy. And then I go to GL dot create grocery list. Now I can start typing in, and you'll see that with the arrow keys up and down, you can see what overloaded options you have. This is a great time for us to talk about XML documentation because this is primarily where you're going to use it. So let's do that. XML documentation is initiated by 3 forward slashes. 1, 2 is a standard comment. Standard single line comment is 2 forward slashes. We talked about that earlier in the show. Not this episode, but earlier in the series. If I hit one more, Visual Studio automatically types out the summary parameter names for every parameter that you would have in here, and then your return type. What this does is it allows you to create tooltips later on in Visual Studio. So summary, give a rough idea of what this method or function is meant to do. Creates a grocery list object and from with a specific name. And then in name, we'll do grocery list name, and then returns. This documentation, summary, param, and returns, allows us to go to other parts of our code that we want to create a grocery list from, like GL, go to create grocery list, and see what we entered in. Creates a grocery list object with a specific name, and it returns, the grocery list name is what we want to enter in, so we'll just give it some dummy data there. And then when you hover over this, is it going to tell me? Of course not. I'm actually not sure why it's not showing me the return value, but that's easy enough to fix. You can just take this text here and append it to the end of the name. Easy enough. So now you should be able to see create grocery list. Creates a grocery list object with a specific name, returns name of generated grocery list. We pass in the grocery list name. Pretty straightforward. There's a lot that we could go over with our methods and functions, event handlers, and so on. I could try to hammer it all into one video, and I could certainly go on and on, as you've seen, for well over an hour, talking about different specifics. I think the best way to get a handle of this is to see it in action as we go through code moving forward. In this particular case, I don't think it makes sense for me to just slam it all into one video, make it 2 hours long, and expect you to watch it. What I'll do is I'll leave this video here and try to explain the methods and functions I'm writing as we go along. Why I'm passing in values, how to access passed in values, how to manipulate data, how it's relevant in the scope of that data within the method or function, and then how it's returned and interacted. We'll also at some point later on down the road have a class about architecture, more than likely, talking about how to design software and how to be prepared for the unexpected while still being unable to expect it. It sounds more like an art than a science, and to some degree it is. That's because you're inherently working with a flawed system. You're working with computers designed by humankind, and you're writing code that will be interacted with by users, which are typically humans. So you have to be able to capture as much as you can, but it's just not going to be perfect. There's a reason application maintenance is a thing. So this has been methods, functions, event handlers, access modifiers, so on and so forth. I don't even know what I'm going to title this video at this point. Maybe Method to the Madness. Working title. But I appreciate you coming out. We're real close to being able to just jump in and start designing an app from scratch. And I think that first application is going to go away really, really soon because there's no reason for us to hang on to it. I have a feeling that our next episode is actually going to be removing us from Windows Forms and moving into the technology stack of WPF, at least as best as I know it. That'll be a fun bridge, because I think that the more modern feel, the more modern capability that you have with WPF will really help you design a system that helps you wrap your head around the system you're designing. And that seems backwards and weird and awkward, but sometimes you have to fly before you can run. So, thank you. And until next time, have a good one.